Hello, my name is Brionna Colson-Fearon, and today I will be solving review question number 10 on page 525 of the textbook. The question asks, what is the dispersion force? What does the magnitude of the dispersion force depend on? How can you predict the magnitude of the dispersion force for closely related elements or compounds? So this question is asking a few different things, but we are going to take it step by step. The first question it asks is, what is the dispersion force? Dispersion forces are a type of intermolecular force. Other types include dipole-dipole interactions, hydrogen bonding interactions, and ion-dipole interactions. Dispersion forces are the weakest of the four. They are found in all molecules, but more specifically seen in those which are nonpolar, meaning their electrons are evenly distributed throughout the molecule. Dispersion forces create induced dipoles, which occur when there is a temporary uneven distribution of electrons throughout a molecule, causing one end to be more positive than the other. The second question asked is, what does the magnitude of the dispersion force depend on? The magnitude of dispersion forces depends on the size of an atom or molecule and the shape of a molecule. Molecules with a larger molar mass will have stronger forces. One way to illustrate this would be to compare the strength of the forces between various types of alkanes. Alkanes are hydrocarbons where all of the atoms are connected by a single bond. The amount of carbons in which an alkane contains can be determined by its prefix. For example, propane has 3 carbons while nonane has 9. A good way to compare the strength of intermolecular forces between alkanes is to look at their boiling points. Higher boiling points mean stronger intermolecular forces. Propane would have a lower boiling point than nonane because it has a smaller molar mass, meaning that it also has weaker intermolecular forces. The magnitude of the dispersion force is also dependent upon the shape of a molecule. For example, if you look at pentane, it has many constitutional isomers, meaning there are many different shapes it can take. The isomer which is more linear will have the strongest forces, while the isomer which is more circular will have the weakest forces. This is true for all molecules. The more linear the shape, the stronger the force. The third question asked is, how can you predict the magnitude of the dispersion force for closely related elements or compounds? In order to do this, all you have to do is look at the size and shape of each molecule as I mentioned before. Thank you so much for watching, and I hope this was helpful.